Okay, for our next inductive proof problem, we've been asked to show this is true via induction, so that the sum of all of these terms here is equal to n over n plus 1. As with all inductive proofs, we're going to start off with our base case, and in this case we're going to let n equal 1 and show that that is true. So we just need to show that this term here is equal to that term there when n is equal to 1. So we have 1 over 1 times 2 from here, which is going to be a half. And from here, we've got 1 over bracket 1 plus 1, which is 1 over 2. That is that, so therefore our base case holds true. Now on to our inductive step. And our inductive step just says this, adding another term, we have to show that that is equal to this if we replace n with n plus 1. So writing out all the terms explicitly, 2 plus 1 over 2 times 3 plus yada 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 plus 1 on n bracket n plus 1 plus our new term, which is 1 on bracket n plus 1 n plus 2, right, equals this when we replace n with n plus 1. It's going to be n plus 1 over n plus 2. Now, because we're using induction, we can assume this statement here is true. And so we say, if this is true, then the good news is that by starting from this line here, we can see all of these terms here can be simplified to this. So we can take all of these terms and we can rewrite them as n on n plus 1 plus this term here, which we haven't managed to get rid of, n plus 1 times n plus 2. And now we just want to show that this, if we massage it around a bit, will become equal to this. What we want to do is we want to get everything over the same common denominator, so I just want to multiply this side by n plus 2 over n plus 2. So that's going to give me n bracket n plus 2 on n plus 1, n plus 2, plus 1 over n plus 1, n plus 2. Okay, moving that up a bit. Now these are on the same common denominator, I can expand this out and I'm going to get n squared plus 2n plus 1 over n plus 1, n plus 2. And hopefully you'll notice if you factorize that, it's actually just n plus 1 all squared. So if we replace that with n plus 1, that cancels with one of those, and we get left with n plus 1 over n plus 2, which is exactly what we required before, and our inductive proof is complete.